Okay, here's the continuation of our 2.1.2 notes. And the first problem is a try on your own proof. So now would be the time to pause, come back, check your proof against mine. Okay, here is the proof that I created. I did have to get a little creative with my space. So I used the fact that AG is parallel to PR here. And then once I put the parallel markers in there, and I imagined actually extending those lines. And then once I extended those lines, I saw that angle A and angle P would actually be corresponding if I slid one over to the other. So I just did that as a tool for myself. So GAP and RPH are going to be corresponding angles. So let me get those markers out of there. But they were helpful to me when trying to determine which angles matched up. Then I used the next part of the statement that was given to me that wasn't congruent, because I knew congruent was going to be easy and there wasn't going to be any bubbles flowing into it. So I did that P was the midpoint of AH, so that's the next bubble that I did that was given. And then I thought about, well, what does midpoint mean? Well, it means that at P to A is the same distance as from P to H. So that's where my next congruence came in. And then I went through afterwards. So at the end, I used kind of the freebie, and that was the one that was given to me. And then I took a look at the picture, AG and PR. I didn't mark in my picture. So AG and PR. Okay. And then you can ignore the parallel markers because they don't tell you that things are congruent to each other. And then once I took a look at this, I was like, oh, okay, that's side angle side. And then once I figured that out, I was able to find that last angle that they wanted me to say were congruent to each other. Okay, there is another way that we do proofs. Actually, there's a whole bunch of different ways that we do proofs. One of the other ways that we do is two-column proofs. It's a lot like what you have done previously. It's just that, so on the left-hand side where the statements are located, these are the things that would be inside the bubbles. And then the reasons, those would be the things outside the bubbles. You just need to make sure that your order makes sense. It's kind of like the order of your bubbles. So like the arrows have to be pointing to the correct bubble. It's the exact same idea with a two-column proof. You just need to make sure that any statement you make is supported by a statement above it in the two-column proof, or it was given to you. Okay, so here we have an example from the notes. So D is the midpoint of MT and AH. Okay, I like to separate my given statements so I think about the bubbles themselves. So I would put in my first bubble the fact that DT is the midpoint of MT. So I would just do one thing at a time. So, and I am gonna color code this one just because it's kind of the first time we've done something like this, at least in our class. You may have done this previously though. So my first statement is going to be exactly what I just highlighted. So D is the midpoint of MT. How do I know this? Well, because it was given to me. I didn't have to do any work for it. Now, I don't like to finish my given statement until I've extracted this information. So I think about how I would do my bubbles. So if D is the midpoint, so D is the midpoint of MT. So from D to M has to be the same as from D to T. Okay, that's going to be the next thing that I say. So line segment DM is going to be congruent to line segment DT. And the reason why I know that is because I used midpoint. So definition of midpoint. So that takes care of the orange part of the given statement. Now I'm going to go back to the given statement. Now I have that D is the midpoint of AH. Okay, so go back to my picture. D is the midpoint of AH. So from D to A is going to be the same as from D to H. Okay, so getting a little ahead of myself though. Let me write my given statement. So D is the midpoint of AH. And that's because it was given to me. Then underneath that bubble, if I did a flowchart proof, I would actually say that DA is congruent to DH. My reason, definition of midpoint. Okay, so that exhausts the blue. All right, if you take a look back up at the given statement, we're now at the prove part. Okay, so this is all stuff that we have to come up with now. So if I take a look at the picture, the only things I'm allowed to come up with are, let's see, vertical and reflexive at this point, really. And I don't have reflexive, but I do have vertical. So I've got this angle, so the top of D and the bottom of D. I'm not allowed to call it that, though. I actually have to be explicit here because there's too many things it could be. So let's do angle MDA on the top is congruent to angle, okay, let's get the one on the bottom, MDATDH. And my reason for that, so what I would put outside the bubble, is that these are vertical. Okay, now I take a look at the entire picture and ask myself, do I have enough information to prove that these triangles are congruent to each other? So I think about my 5 choices. All right, I've got 2 sides, 1 angle. 2 sides, 1 angle. Okay, it could be HL. All right, so if I take a look at this, there's no way it's HL because there's no box in the corner. So if this is congruent, it's got to be side angle side, which it is. Okay, so 6. This is where I name the triangles. Now, I was super careful about how I named the angle, so I'm going to use that same order. So MDA and TDH. Notice that I'm using a triangle symbol though here though. So number 6, and my reason was side angle side triangle congruence. Okay, I'm almost there. All right, I have to be able to prove MA and TH. All right, look at the picture. Should MA and TH be congruent now that the triangles are proved congruent? Yes, I do believe so. So number 7, we've got MA is congruent to TH. Now, I proved the triangles were congruent, which means I can say congruent triangles give congruent parts, or you could say CPCTC. It's up to you. And then I take a look at the problem. I make sure that I actually proved what I was asked to prove, and I believe that I am done. Another way to take a look at this, if you think about the bubbles, however many statements and reasons you have is the amount of bubbles that you would have had. So it's another thing to think about.